I'm going to take you beyond just using Docker and into understanding how to actually work under the hood. In this session, we will break Docker down to its core building block, Linux namespace, Cgroups, Root Filesystem, and most importantly, we will build a mini container runtime from scratch. By the end of this talk, you will not just run containers, you will understand how they create at the kernel level. Problem: what is Docker really? Let's start with a simple question. What is Docker? Most development today use Docker every day. Run Docker build, Docker run, deploy applications with containers. But here is the problem. Many don't actually understand how it works. This leads to common misconceptions. Container is just a virtual machine. Docker is magic. It is some kind of binary format. These assumptions are not correct. The reality is much simpler and much more powerful. Docker is just a wrapper around Linux kernel feature. It doesn't invent something new. It simply uses what Linux already provides. Core idea. What is a container? So what exactly is a container? And its core. A container is just a project with isolation. That is, nothing more. Compared to virtual machine, let's compare it with the virtual machine. A virtual machine has its own kernel, very heavy. A container shares the host kernel, very lightweight. Virtual machine boot time 30 minutes, container start time 30 milliseconds. This leads us to the key formula. Container is process and namespace and Cgroups and root filesystem. If you understand these four components, you understand Docker. Project overview. Mini Docker architecture. Now let's look at what we are building. We create a simple project called Mini Docker. It further represents a core concept of Docker feature. Our mini runtime support: build an image, run a container, execute commands inside container, stop container, limit CPU and memory. Equivalent to real Docker. So we are basically rebuilding Docker in a simplified way. Image, root file system. What is a Docker image? Let's talk about image. A Docker image is just a file system snapshot, not a binary, not magic. In our project, we store image like this. This is just a directory on disk. That folder itself is the image. How we build it? We run this command. This command downloads a minimal Linux file system and equivalent to. So when you build an image, you are basically download a file system. Dockerfile concept. What is a Dockerfile? A Dockerfile is often misunderstood. It is simply a script to build a file system. Docker example. And in Mini Docker, we do the same thing manually. Dockerfiles is an automation of Cgroups operations. It is not special, just automation. Running a container. How we run a container? Now let's run a container. We use this command. And what happened? A new process is created. It has its own isolated environment. It has its own host name, and it sees its own process list. When you run this, you only see process inside the container. This is the moment where a normal process becomes a container. Namespace isolation. Line namespace provide isolation. Each namespace isolates a specific resource. PID, process tree, networking, mount, file system, UTF hostname, IPC, share memory. This is the foundation of container Kubernetes, Docker. Without namespace, container cannot exist. Cgroup, resource controller, limited resource. Isolation is not enough. We also need limit. We use Cgroup. Result. Memory uses is a cap. CPU uses is a control. Cgroup acts like a result firewall. This prevents one container from consuming everything. Networking. How container networking works? Let's simplify networking. In Docker, bridge is a Docker 0. NAT is a IP table. In our project, we only implement a basic bridge, but this is enough to understand the concept. What we build? Equivalent to Docker. Let's review what we added. Image system, container runtime, asset into container, stop container, resources limited. Demo flow. Step 1, grant permission. Step 2, build image. Step 3, run container. Step 4, open another terminal. Step 5, access command. Step 6, stop.